Hello. Arya. Hello.
No, no props, sir.
Okay, so how much time did we lose?
So 15 to 20 minutes.
Okay, we still have time, right? We can continue. Okay, perfect. So how do you want to go about it? So
Okay.
let me share. Uh, do you want to?
Yeah, we start.
Okay, you want me to start?
Is the witness of your word. The silent plants of the water is the witness.
The moment of the moon is the witness of your perfection.
A very good.
Hey guys, can you see my screen?
No, so screen is visible.
The data analytics and the presentation side of it. Data analytics hands-on, I don't know if we will be able to do it because I'm logging from my personal. It's a network of things. They are currently utilizing, leveraging the IoT technology. First one is energy, oil and gas, where a lot of monitoring is done. Petroleum products, they need to be alerted if something is going wrong. Plus, they need to manage their productivity. Manufacturing is another business, be it automotive, be it chemical industry, you name it, and all the manufacturing industries would today have the Internet of Things, different devices to actually monitor compressor, pressure, CNC machines, and whatnot. Healthcare is new booming industry when it comes to IoT technology. Manufacturing is today there are mechanisms, there are technologies available where patients can be monitored remotely. So there are multiple use cases which we will be talking about in upcoming slides on healthcare also. Transportation, I think we all are familiar with transportation in terms of Ola, Uber, be it fleet management, even in different smart cities in India, outside India. If you see the transportation, the status of different bus routes, what is the status of the bus, where the bus is, all those kind of use cases are there in IoT, which is solving many problems of having moving, letting people move to public transportation system. Agriculture is underrated right now. Agriculture is having plenty of use cases which be implemented, be it the moisture, monitoring temperature, different environmental conditions, even the greenhouse and whatnot. So all of those are generally available in IoT space. Retail, everything else is retail. You name it. Like there would be malls, there would be a lot of retail stores. They are monitoring the inventory and things like that. So these are at a high level. These are the key businesses which would cater to the IoT. Now we have touched upon at a business level different industries basically. Now here are the low-level use cases. Many you would be aware about many of them. Could be either in hospital or could be a post-op, be at home where there will be some devices, personal devices, wearable devices. They are advised to put all the time, like Garmin is there, like Fitbit is there, and things like that. But on top of it, since this is there's a requirement of capturing real raw data, not just what these wearable devices generally like devices. Leak detection, it could be water leak, it could be gas leak, it could be any viewable liquid, like where is the driver, is it going, are they stuck somewhere? Those are the use cases which are covered under fleet monitoring. Any questions so far, guys? No question? Anybody there? Can someone say yes, no?
Yes,
Are you able to see this diagram? Because this is important. I don't know.
yes, yes, sir. Everybody could understand.
Diagram is visible, right? That's what I'm looking for.
Yes, sir, the diagram is visible.
Okay. So we are kind of now after going through the overview of IoT, we are kind of jumping on to IoT analytics related components here, and to cover how exactly it would look like. So I don't know how many of you are familiar with AWS, Microsoft Azure. So this is typically, I will be referring a lot of services, a lot of components, which are purely by Microsoft Azure and Amazon, AWS basically. So if you see the reference architecture on the left-hand side, here are the devices. These devices could be the microprocessor, could be connected to PLCs, connected to different sensors, native protocols like Modbus or OPC. Left-hand side, acquisition layer. This is the acquisition layer on the left-hand side. And then we have the gateway, which is more or less the Azure IoT Edge. So we'll have a gateway which will be kind of talking to the cloud for data ingestion. So this one, which is ingestion and provisioning, this is more or less an entry point to the cloud space. So on the left-hand side, IoT Edge will be talking to low-level devices, and it will be sending data to the cloud. Cloud will have multiple possibilities. Here, IoT Core, what you see IoT Core in this color is for AWS, and this is what you see is actually Azure services. So in this color, it's AWS, and this one with the diagrams with the images are actually representing Azure. So they are equivalent, meaning Azure IoT Hub in Azure is kind of same as IoT Core in AWS. So this is more like an interface. It will allow you to get the data from IoT Edge and then start processing. Device provisioning service is important. There may be thousands of devices which will have to be provisioned on the cloud before it actually acquire the data. Azure Digital Twin is another concept. Each and every Azure Digital Twin is like a representation, a digital representation of the asset, what is there on the left-hand side generally. And then there would be a device twin. Device twin would represent a specific device. So once the data is received here for in ingestion and provisioning layer, what you see here, there are three different categories: hot path, what you see here, the warm path, and then the cold path. Hot path would be more of the real-time data analytics, real-time data processing. What you see here is Kinesis is AWS, and Azure Stream Analytics is Azure. So this service, this component is responsible to do the analysis in a real time if you follow this path. Meaning, if there is any high alert alarms, it will follow these paths. So, for example, if the temperature of a particular machine is this is what the high-level reference architecture would look like typically. So can I have some reaction, any question, any doubt on this? To gain some idea from you. Making sense what I'm trying to explain here?
Yes. Yes,
Okay.
sir. Everybody didn't have the access. So whosoever have any questions, they can raise hands and we'll allow.
Oh, okay. So no problem. So let's move on to the next one. The next one, this was more like a generic architecture. A typical IoT reference architecture would look like these. Only solution. This is not the only set of components or the services. depending upon the different problems we are trying to solve, these components will change. Jumping on to very, very specific use cases. This is a use case for one use case. Here, what I think the patient data by means of collecting it devices. If the person is having a wearable device, then medical devices and the different sensors, these are generally installed if the patient is under care, maybe in hospital or home care. So these devices may also be applicable. So these devices can also send data to the cloud for analysis. At the same time, there will be systems, CRM systems, EMR data sources, other data sources as well, which will be required for information. So the patient-related data may not help, right? So if we are saying heart rate of the patient is this, temperature of the patient is this is possible here by just collecting data from wearable devices. Now we have to see the history of the patient with respect to what was the medical history of the patient, what were the previous problems and stuff like that. So that data will flow from here to here to this analytics space, which is Azure Synapse Analytics. So this Azure Synapse Analytics is basically playing a pivotal role here to do the data analytics part, joining all the data, not only the telemetry data. So data which is coming from wearable device is a telemetry data. Okay. And the other data is more like a contextual data. Even medical devices, the data coming from these medical devices are telemetry data. So all these three data points coming from devices, coming from medical devices, coming from wearable devices, and then coming from their own medical record, the machine learning module. So it will basically have a machine learning module which will analyze how the patient is behaving, how the history of the patient was, and a pattern will be derived to raise an alert to the physician saying this patient requires some attention. So this is a use case typically which is used in technology. This what you see on the middle column is the main data processing analytics space. So Cosmos DB is no SQL database. It can store JSON document that can be aggregated. There will be a raw data processor. The data can be aggregated. It can be analyzed as a time series data and can be stored in different containers to capture a different level of information about the patient. All this together can actually help doctor to take some kind of medical decision. So this is one use case, and the report can be shown using different tools like Power BI, even the web app. They can be integrated as well in the mobile app. So this is a typical healthcare architecture. I just wanted to bring here as an example. The next use case is industrial use case. In this, it's a manufacturing company. It's a small company. They have, say, for example, if they have few machines, in this case, they have CNC machines. They are producing some products. They want to monitor their machines, how exactly it is going. How exactly it is going in the sense, is there predict a maintenance cycle? And what exactly is the temperature? What exactly is the other parameters of that specific machine? So assume this is a machine, then we will have to have some kind of adapter here. I'll not go in detail. In order to get data from CNC machine, we have to have some kind of adapter and agent combination, and that will be kind of integrated with the local IoT device, on-premise IoT device. That IoT device will be able to some command and control to be issued locally within on-premises to achieve some kind of automation. There may be very little or maybe very limited use cases which would require some kind of command and control coming from the cloud. So this is one space on the left hand side for people who are interested to low level device integration. Software development will be there, and then the device level SCADA PLC programming will also be part of it. In the cloud side, every box what you see itself is an expertise. Take an example of Power BI here. Power BI is Power BI or QuickSight. That's AWS QuickSight and Azure Power BI. It's an analytics tool used by used in different projects depending upon the type of requirement. So typically there will be a team specifically only knowing Power BI or QuickSight. So there will be a set of people, they will be like subject matter expert of dealing with Power BI, preparing dashboard, preparing analytics at that UI level, getting data from Power BI low level containers, getting it integrated with Synapse or anything else, something like that. Similarly, if you see here in one of the slide, database, right? So this is no SQL database. Cosmos DB. They would know in and out everything, how to make it perform better, how to make it read optimized, how to do all kind of things at a database operation level. Similarly, Azure Synapse Analytics is just another example for people who are interested in hardcore the analytics, the data and processing side of it. Machine learning itself would be another example here for gaining some kind of expertise. So there may be people, they may want to only work in machine learning. So there are multiple use cases in machine learning. Computer vision and low level deep learning and things like that are the opportunities here. So there may be few things which will be overlapping with IoT, or they may be not really relevant to IoT, but these are the technology which are kind of in demand right now. So data flow architecture, this is what we have covered, and this is what we wanted to do, but unfortunately my other laptop is not working. I wanted to show something. Maybe we can open the Q&A session if you have people interested to ask question. Ishika,
Yes, sir.
Yes, sir.
so this is pretty much open for Q&A now. I'll still see. Do we have some time? Do you want to see the hands-on?
Yes, sir. Yes, sir.
Okay, so
We
anyways,
have
this
we
is
have time till 4.
right.
Time till 4.
So this forum is open for Q&A. I don't know if there are people who would be having any question. I would love to answer those questions, very specific questions. That will also help me to understand what kind of audience we have and what exactly they are looking for. And I'm all here to answer those questions. So let me try, while I'm waiting for some of the people to actually ask questions, let me see, I can set up something quickly to show you something.
Excuse me, sir. 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 Excuse me, excuse me.
Yeah, any question?
Yes, sir. Actually, there are some sensors of IoT, like that collect temperature data, and like some sensors are there which collect like there are smart cities. In smart cities, what happen is like, can you hear me?
I can hear you, but I can hear the echo also.
लेकिन जो बोला मैं यहाँ से ऑन कर दूँ ऑन कर दूँ ऑन कर दूँ ऑन कर दूँ ऑन कर दूँ
Hello, sir. Can you hear me?
Yeah, I can hear you.
Hello, hello.
जब तक नहीं करूँगी तो यहाँ सुनाई नहीं देगा और यहाँ से करूँगी तो एको चली जाएगी क्या प्रॉब्लम
Can you guys hear me?
Yes, sir.
So is there any question?
Yeah, they're gonna type it in the chat box.
Oh, okay. Someone was talking. I was able to hear him, but he was not asking the question.
Issue. There was some kind of issue, so he's gonna type it in the chat box. We can read all the questions in the chat box itself.
No problem. No problem. Okay.
Okay.
Okay, let me share again. I may not be able to run the program because my laptop is not there, but I can share something. Can you guys see the screen again?
Yes, sir. We can see the screen.
Okay, so I don't know if you guys remember. So I was talking about IoT Central. IoT Central is the interface which will be, and this has multiple analytics tool available inbuilt. This is an application platform as a service. So when I log in to the IoT Central after creating one application, it will look like something like this. Okay, so you can see if I go to devices, I can actually provision. I can actually create devices here. I can add devices here. So I have added one device, VIT test, to have some kind of analytics demonstration, but I cannot run the code because I don't have access to the other computer right now. Here you can see there is something called device template. So if I go to device template, if I go to that healthcare application, right, which says watch data template. So this is the wearable device. I was trying to give some demonstration to you so that you can relate it with what I'm talking. So for the healthcare technology, the healthcare, say for example, there is a wearable device is recording heart rate, temperature, and there is a property which says what is a desired temperature. temperature is a property which can be, say, for example, 98 Fahrenheit is the normal human temperature. So the desired temperature is 98 Fahrenheit. So that can be defined here in the model. This is more like a model which is device model. You can see how exactly programmatically it will look like. It is a JSON data structure. This is a model which is digital twin definition language. So this is the way, say, create a query. If I go here and say create a query, and if I say this is the template I'm using, this is the heart rate I want to analyze, this is, I want to group it by device and say analyze, it will show some kind of data which is not very interesting right now, because the device is like not sending enough information right now. So it will show some kind of analytics like this. This is basic Azure Data Explorer, which is kind of offering multiple things. Period. You can select here. You can say what should be the interval. Should it be 1 minute, 5 minutes, and stuff like that. And it will analyze data for you, and it will show. So if I want to see like 1 minute data, it will show something like this at a level. Check the VIT test. These are two devices, for example. Similarly, dashboard is another tool where we can go and create different kind of reports. This is a basic demonstration. So, for example, you can analyze this heart rate. So all these options, KPIs, last known values, line chart, bar chart. Let's say I'm interested in having a line chart here for heart rate in this case. So here I can go edit, select, I can say health status or something like that. I want to see past 12-hour data, maybe past 12-hour data. And then I want to see at 30 minutes interval. Device group I can select, watch data template, and then what are the different devices. Only one device is there for this template. I can add telemetry capabilities here, which I'm interested in, say heart rate. And then I'm give some kind of coloration here, and I say update. Again, this is not interesting because the device is not on right now. So you'll see very limited data here. There's no pattern visible as such, but you will have these kind of option here. Now, this is more related to capturing the data and visualizing it. How exactly we use it? Say, for example, it's fine to have this data, right? Data analyzed by these tools. If these tools are not there, developers will have to write their own program and make these visualizations available to the users or to the physicians, to the doctors. Now I want to set some kind of analytics here, saying I want to set some kind of alert where I will have a rule saying fever alert, for example. I want to set a fever alert where I'll say that, okay, this is the template. All the conditions should be true. And then I want to aggregate it. I want to say I want to do aggregation for 5 minutes, meaning I want to check average value every 5 minutes. And then I'm interested about in heart rate. I go here, sorry, not heart rate, temperature. We're talking about fever. So we'll say is greater than, if the temperature is greater than certain value, and what exactly is the value here. So either you can say 98.0 here, or you can say select value. Select value can be the desired temperature. I don't know if you guys remember, desired temperature is a property which is kind of set for 98 Fahrenheit, for example. So this is how you set the analytical rule here. So the analytics tool will analyze the data for the last 5 minutes. It will keep on doing it on top of live data every minute. And then once this condition is met, what action you want to take? You want to send an email to the doctor saying this patient is not doing well, or you can send some kind of SMS alert. So the action options are also here. So you can go and say fever alert. It can be anything, right? It can be anything, and then you can mention the email address here, and you can do whatever data information you want. So that mail will be sent to the person who can actually take some kind of action on top of it. So this is what I wanted to show, guys. Unfortunately, I had the device also. I wanted to show you running, but I can't do it because of some technical issue. So this is pretty much I wanted to cover. Now again, I'm opening this for question and answer. So do we have any questions, guys, on the chat, or if anybody wants to cover, if anybody wants to read out the question, I will be happy to answer.
Yes, sir. There's a question in the chat itself. Should I read the question?
Yeah, please do it.
In smart cities, there are IoT sensors everywhere to collect data. How that data can be helpful to us? What else can we predict from the IoT data?
Correct. So see, smart city is just one use case. I can give you example of say France or Netherlands or some of the European country how they utilize this data. One of the aspect I want to touch upon, the sensors can be n number of sensors when we talk about smart city. Let me give you example of a transportation system, a public Pune, all the metros of India, or maybe tier 2 cities. People generally don't go by public transport. People who can afford car, they generally buy car and they use it, which is not good for the society. Looking at we have, it's not that they don't want to use public transport, but there are limitations. There are some bottlenecks. Because of that, they don't want to use public transport. So in this case, for example, you have a car, you can go take out and go wherever you want. Public transport information is not available to you as and when you are getting out from your home. Even if you want to take, say, for example, a bus service, you have no idea where the bus is, how long you are going to wait at the bus stop. Is the bus is already available or it's already gone? You have no idea about it. So the way this problem is solved is making some kind of GPS data available to the user as a dashboard. Today, all are using their smartphone, so there can be app which can actually tell you what is the current location of the bus, and accordingly you can manage your time. So you know that the bus is coming to the stop in next 10 minutes, and it may be late, it may be whatever it is, but you know exact time when it is going to come based on the GPS data available. So that way this problem can be solved. This is one example, right? Now, in terms of sensors, if you want to name any specific sensor, we can discuss in detail. There may be sensors for collecting garbage. checking if the garbage is full, what is the condition of the garbage. There may be sensors, or there's something called computer vision. So if there is a big garbage area which you want to monitor, even in a smart city, if you want to monitor the traffic, right? So today, how the traffic lights are operated, it is fixed, meaning irrespective of from which direction the traffic is more, irrespective of that, it will kind of show red light for a specific duration. Even if there is no vehicle on the other side, the people will have to wait. So there are sensors, there are use cases, computer vision use cases there, based on which we can actually check which side of the road is having more traffic, and which side of the road would require some kind of traffic, clearance. Accordingly, those signals can be made smart. So these are some of the use cases which are kind of combination of sensors plus some kind of camera, computer vision, and GPS technology. I
Okay.
hope this answers the
So
question.
yes, sir. We have a few more questions. Can you please guide us as like a roadmap for the if you want to go further in this field?
You actually think about anything else. Generally, you should have idea about everything. So the roadmap should be to actually one of the technology to the fullest. You should be master of at least one or two services or specific technology. So that's how it is. In terms of IoT, as I said, there may be some overlaps between different jargons you may be hearing these days. Machine learning, deep learning, artificial intelligence. So there may be overlaps depending upon which business we are talking about, which industry we are talking about. So today, if you are solving a problem in an industry which is an IoT problem, computer vision, machine learning, right? So there are multiple projects we are doing in team. Different teams are doing it. So based on your interest, you can define your roadmap and focus on at least one or two technology to gain some kind of expertise.
Yes, sir. And one more question is asked by here only students only that what kind of interview questions we expect if we go further and they're like interviews. So what kind of interview
Okay.
questions?
Yeah, so as I said, depending upon what role you're applying for and what level you are applying for. If you are applying as a fresher, there will be very limited questions on IoT. It will depend on you only, how you project yourself. If you can master any of these technologies upfront before even going for the interview, then nothing like it, and that should match with the requirement. Say, if you know that the company is looking for machine learning expert and they want to train somebody in machine learning, or they are looking for computer vision expert, or they want to train somebody on computer vision. Now, if there are two candidates, one is having some appetite, and because of that appetite, if the person has already learned something on machine learning or computer vision, and if that can be demonstrated by the candidate, uh, then it does not matter what question interviewer was prepared to ask. What I'm trying to say here is, you can drive the interview. As a fresher, you are free to drive the interview, and you should be driving the interview. You should be talking about things which you know. As simple as that.
No more questions.
Yes, sir.
IoT specific questions could be again role based, as I said. If you're applying where device integration knowledge is needed, networking knowledge is needed to connect with Modbus, or connect with OPC UA, or connect with RS234 or RS232 or whatnot. A cloud interview could be AWS, depending upon what they are looking for. So nowadays, everything is going low code, no code. Okay. So there is something called low code, no code, meaning I demonstrated few things, right? There was no code involved. That is the kind of trend right now. So you should be mastering some of the tools. If you are interested in uh, uh, data analytics, look at Synapse Analytics, try to master Synapse Analytics at a professional level. If you are more interested to design dashboard, go for Power BI or something similar in different kind of platform. Any other question? Anyone?
कैमरा ऑन नहीं हो रहा. Is there any questions anybody have to ask? They can ask. Ladies and gentlemen.